So let's introduce an important new idea, which are called multiples in mathematics. So it may seem very simple to you, but again plays a very important role in elementary school mathematics. And later on, let's look at multiples of 3. What do I mean by multiples? So by multiples, I mean nothing more or nothing else except numbers that appear in the multiplication table. That's it. And not too hard, right? So numbers that appear in the multiplication table of a particular number are called multiples. So let's look at a number like 3. So if I look at a number like maybe 3, so you can see that multiples of 3 are 3 because 6, 9, 12, 15, 18, 21. And the reason why I'm putting all of these numbers out is because 3 ones are 3, 3 twos are 6, 3 threes are 9, 3 fours are 12, 3 fives are 15, 3 eights are 20, 3 sixes are 21, 3 sevens, sorry, 3 sixes are 18, 3 sevens are 21. So all these numbers are multiples of 3. Now note, it's very important, and you can see the relation that if 12 is a multiple of 3, so let's say 12 is a multiple of 3, this is the same statement as we talked about this earlier, that 3 is a factor of 12, right? Why is that? Because 3 being a factor of 12 really meant that you can divide 12 by 3, right? So 12 over 3 is equal to 4. And 12 being a multiple of 3 really means that 12 is equal to 3 fourths. And you know that these two statements are the same statement in how division was defined. So that means that these two statements are the same statement. So let's do a few problems and um, see some interesting facts. So let's pick any multiple of 3. Okay, so let's take a random multiple of 3. Let me take 123. Okay, 123 is a multiple of 3, and I'm just going to write it. It's 41 times 3 is 123. So this is a multiple of 3. Let's look at another number like maybe 726. This is also a multiple of 3 because 242 times 3, if you were to do it, you'd find this is equal to 726. But what you find is a very interesting fact, okay? And this is kind of a fun fact that you can think about, that if I add 1 plus 2 plus 3 and I divide it by 3, this is just equal to 6 over 3, so this is equal to 2, which means that the sum of the digits of 1, 2, 3, the sum of the digits 1, 2, 3 is also a multiple of 3. And if you try another number, the same number like 726, 7 plus 2 plus 6 over 3, but this is just equal to 15 over 3, which is equal to 5. So this is also a multiple of 3. So the sum of digits is also a multiple of 3. It's not true in general. So let's look at a number like 49, right? So if I look at 49, here's 49. 49 is a multiple of 7. So 49 is a multiple of 7. Why? Because it's 7 times 7. But if I add 9 and 4, I can't divide them by 7. 9 plus 4 over 7 is 13 over 7. And that's certainly not a whole number, so you can't do that. This is not a whole number. So 7 is not a multiple of the sum of digits. But it's something very peculiar to 3, And if you're curious, you'll find out about it when you learn about algebra. The beautiful thing that you can do with algebra once you get to middle school, and you can prove this fact for yourself. Okay, so now let's introduce a new idea which is called common multiples. So let's think of two numbers like 4 and let's say 6. Okay, I have two numbers, 4 and 6, and let me think about multiples of 4. So if I look at multiples of 4, what do I get? If I'm going to look at multiples of 4, I'm going to get 4, 8, 12, 16, 20. I'm just going through the 4 times table. 28, 32, 36, 40, goes on. If I look at the 6 times table, I'm going to get 6, 12, 18, 24, 30, 36, 42, 48, and then it just goes on. And let me add another one, which is okay. So now so these are the multiples of 4 and these are the multiples of 6. Now we can look at numbers that appear in both the rows, which are the common multiples. So this is an important idea, that we want to look at the common multiples. So what are the common multiples? By common multiples, we mean exactly those multiples which are common to both the rows. So if you look at the common multiples, then you can see that 12 appears in both the rows, 24 appears in both the rows, 36 appears in both the rows, and if I had continued this was 44 and 48, you would have seen that 48 appears in both the rows. So if I write down the common multiples of 4 and 6, I would get 12, 24, 36, 48, and so on and so forth. So these are called the common multiples of 4 and 6. So you can compute the common multiples of two numbers fairly easily. And now you can also, please make sure you can also compute the common factors. So let's just think about it, the same numbers. So let me just go to with just 4 and 6. So let's try 4 and 6. Let's look at the common factors of 4. Well, if you look at the factors, if I'm looking at the factors of 4, the factors are going to be 1, I'm going to get 2, and that's about it, and 4. So these are the factors of 4. So if I look at the factors of 4, this is what I get. If I look at the factors of 6, I'm going to get 1, 2, and 3. So if you look at the common factors, 1 is a common factor and 2 is a common factor. So the common factors I can write down, just as I could for the common multiples, I could write down the common factors. The common factors are 1 and 2. Okay, so for example, if I have a problem like maybe I want to find the common factors of 36 and 63, so find the common factors, and I want to know which ones are the common factors. So the choices are 3, 4, 6, 9, or 12. Are any of them the common factors? Well, clearly you can see that 3 divides both 36 and 63. 12 threes are 36 and 21 threes are 63. 4 is not a common factor. 4 does not divide 63. 6 does not divide 63, so it's not a common factor. 9 does not divide, 9 does divide 63, I'm sorry. 9 does divide 63 because 9 sevens are 63 and 9 fours are 36. So 9 is a common factor, and 12 does not divide 63, hence 12 cannot be a common factor. So you can see that 3 and 9 are common factors of these two numbers. So please note that common factors, while you can get confused, are different from common multiples. These are two different concepts and they are both very important.